In this video, we will go through the video synthesizer of neuroframes. We will understand how frame-by-frame generation works. We will go through all the sliders, all the settings, and understand why this is a powerful way to generate AI animations. This video is split into two parts. First of all, we will go through the sliders more in a practical sense, how we can use them, what effect they have. And in the end of this video, there is kind of a section where I will make some drawings and explain how the generation process works under the hood. This is just for those that are interested and completely optional. So we are in the video editor. The way this works is we have the timeline here, like in any other video editor you would imagine. You can place elements here by double-clicking. And then we also have modulations and audio here, which we will get to a little bit later. For now, we will only be concerned with the first row here, which is the prompt input to the videos that we create. And then we have all kinds of parameters here. On the left side, under AI effects, there's parameters that sound a little bit cryptic, perhaps. And on the right side, there's parameters that are perhaps a little bit less cryptic. These are camera controls. The left side is AI controls. And then, of course, because this is kind of a new way of generating visual content, these parameters are also kind of new. In general, we can, when we have one of these elements here, we can, for instance, make it, let's say we make it 1 second long. We can just click on create, and we will actually render this section. You can see now that the frame count will increase. This is real time now. It will just increase. You can see frame after frame appearing. And then we end up here, right? And we can play it back, the video, the 1 second that we created. We didn't create exactly 1 second. There are a little bit of rounding errors you will see. Those are due to the smooth value, but this already goes a little bit too much into the detail. Now, if we like this, we can drag this component out, and then we can continue to render it either from here, or we can decide we render it from, I don't know, frame 10 of 23. What this will do, it will override the frames that came after this frame count, and then we will again render frame after frame here. We can interrupt at any time, and then if we want, we can also change things. So now we have this video here. With spacebar, you can just play, right? We can put another input here. And now, for instance, don't say maybe vibrant film poster stylized after a pop art painting with high rich colors, but instead we could perhaps make this vibrant poster of a cat for fun, okay? In between these two boxes, you will see a dark gray box, and you also see this hover state transition. This is kind of a crossfade, but a crossfade in a bit of an unconventional way. It will basically interpolate from all the settings of the first clip here, which is this prompt and all these parameters, to the settings and the prompt of the second box. So we will have kind of a smooth transition of the prompts and all the settings. I will go through this also a little bit later. Now if we create, if we play this back, we can see nicely that indeed the squirrel became a cat. And this is the way you tell stories in this frame-by-frame animation style, or at least this is one way to create stories, by putting prompts after another that somehow morph objects into other objects. Very cool. Now let us go to these settings here, because those are very important to achieve the perfect amount of control. I rendered some examples where I zeroed out all the camera motion, and then put smooth to 1, edge and tile equal to 0, and flicker to 100. And now, and this is the thing I want to talk about, the strength to the 0.8, so a relatively high strength. Let us try to understand the strength first. The strength is really one of the most important parameters here, and this is how much the AI will change from frame to frame. How much the AI will add to the existing images from frame to frame. And you will see that here there are a lot of changes from frame to frame, okay? Somewhat perhaps undesired. Some people also like this, but it is a lot to consume this kind of visuals, I would say. Okay, then let's say we pick a low strength. Same settings, just a lower strength. And what we will see is the changes are much lower from frame to frame. right? This seems much smoother in general. But you will also find that the images start to degrade a little bit over time. And this is just because the AI doesn't add so much new stuff per frame, and then somehow you get these weird, a little bit parasitic effects here. Okay, so strength is responsible for how much new stuff is being added from frame to frame, and also kind of a slider for the quality of the output. Now, we have introduced a slider that we've called Edge Echo. What the Edge Echo does it keeps the edges in the images at the same position, or at least it tries to keep them at the same position. And what we're doing in this example is we have a first box with, let us first just play the first box here. You see that the strength is somewhat high, right? And so we see a lot of changes from frame to frame, but the squirrel stays where it is, more or less. And this is because we have this edge echo here, which resides in edge stability. Then there are still a lot of changes, but those are more the colors and what's on top of the edges. You can really see the edges stay where they are. Nice. And in this very example, we also doing something else, and that is we bring the smooth, which was always 1 up until now, we bring it from 1 to 7. And now let's play it back. You will see the smooth will change from here to here. The smooth is really how smooth the animation is going to be. You see here, we actually put interpolation frames between two AI outputs, and so we smoothen out the whole thing a little bit. And later on, I will explain what this means exactly. For now, I think these are nice settings. Many people have smooth around 3 to 7. You can also make it ultra smooth. In this example, I have smooth 40. You see that the rendering is very fast with smooth 40. And then it barely changes from frame to frame. This is a mode that is also, I always find it interesting, but the real cool NeuroFrame stuff happens, I would say, with smooth 1 to 7, I would say. Most people keep it between 4 and 7, something like that. Now, another slider that is interesting is Flicker. Flicker is a little bit of an advanced mode. Our biggest power users these days swear on Flicker as the main control to achieve what they want in the animations. But it is a bit tricky. It behaves in strange ways. So here I reduced the flicker. And as you can see, I increased the strength to 1. So you would expect now a lot of change from frame to frame, but actually this doesn't happen. If you reduce flicker, there's not so much changes from frame to frame. You can see that it kind of goes without this flickering from frame to frame. It's more of a smooth transition in a sense. But there's all kinds of problems with this mode. It's hard to achieve camera motion. You can increase the edge echo and then move the camera, but it's a bit hard to do sometimes. So if you're a beginner, I don't know if you need this. These are settings that work, and then you can also use nice modulations. We will talk about this in the next video. But yeah, you don't really need this. Great, and then of course there's camera motion. We could just, I don't know, start zooming in a little bit. First of all, the first clip here has no motion at all. Then we start zooming in a little bit. And then we could start rotating a little bit. And let's render this. Let's play this back. First of all, no camera motion. Then we start zooming in. And then we start rotating clockwise direction. That's all you need to know. These are all parameters that are great for playing. We have these presets here, which you can also use. Many people use them at least as maybe starting points. I think that's a good idea always. In general, you want the strength between 0.4 and 0.6 or 7, I think. Edge echo a little bit, not too much. Tile echo is a bit of a strange effect that adds mosaic tiles, as seen in these examples here. And then the flicker I usually keep around 100. Now for those that are interested, let's dive into how everything works. So NeuroFrames is based off an image generation AI, which is called Stable Diffusion in most cases. It's an open source image generation AI that takes text, for instance, a squirrel, and makes an image out of it. Okay, so this is our text prompt, and then we get an image out. Stable Diffusion also has a mode where it's image to image, where we also feed an image in. So we feed a text in and an image, and it creates an image. And this is actually the mode we are in most of the time. What we're doing in neural frames in animation mode is we take the image that comes out here and feed it back into the input again. And so we have this feedback algorithm where an output image is used as an input for the next image. And this is how our animation works, okay? So we generate an image and we use the input image again to feed in as the next iteration in Stable Diffusion to create the next image. And so now you understand also why we prompt in a certain way. We cannot prompt, for instance, for a dog turns into a cat, turns into a squirrel, because the AI doesn't really know the history of the project. It only knows the last image. So you need to prompt first for a squirrel, and then for a dog, and then for a cat to achieve this kind of morphing. And so this is a little bit of a weird animation style, but this is how it works. You can imagine the AI as an oven, okay? It's an oven where the images go through like a toast. It's like in, you know, these automated ovens where things go through and get hot. So this is kind of a conveyor belt where the images, where the data passes through, okay? Now the strength is kind of the speed at which the items go through here. So a low strength, the images will speed through here and the AI will have almost no impact onto the image. With the high strength, the images are very slow and get heated up and changed a lot by the AI. Okay, so high strength means the AI has a lot of effect on the image, and the low strength means the AI doesn't have a lot of effect onto the image. Now, also, we have the edge echo and the tile echo. These are just feedback algorithms where we use the image and put different filters on it to kind of rebake the features in there. So edge echo actually takes the edges of the image. There's a certain type of algorithm, it's called the Canny algorithm, for those that know this stuff. And this takes only the edges. And then we show the AI, keep these edges the same for whatever happens. Do everything you want, but keep these edges the same. And so this is what we call edge echo. And then the tile echo is a different type of algorithm that we put on top of the input image and also tell the AI, here's this kind of stuff, keep it where it is, please. And the AI says, okay, yes, sir. Yes, ma'am, and creates the images. Okay, then we have the flicker. The flicker is basically how equally this often acts from frame to frame. It's kind of how random this whole process is. And low flicker means it's not very random, but actually randomness is also kind of desired in an AI. There's always kind of noise applied, and if the noise is not very random, then you get kind of a weird effect, and that's why we need to increase the strength a lot when we decrease the flicker. Okay, and then the smooth is actually we're acting on in between. So we're adding smooth kind of here. So the smoothing count, the smoothing number is really, if smooth is 5, it means we're adding 5 frames between 2 AI outputs. So we calculate first previous AI output and then the next AI output, and in between we put 5 frames with a smooth 5, and this kind of smoothens things out. With smooth 40, we calculate 40 frames and put them in between, and this is how everything gets a bit smoother. Okay, this was very complex. This was just a bit of background. You don't really need to understand this to play with neural frames. This is just for the cracks that want to understand what's going on. Thank you very much. In the next video, we go through the modulation and the audio stuff, and see you there.